Oh, it says it's recording. Okay, cool. So hello everyone, and welcome to the first webinar of DataFlint. And the topic is the Lakehouse and agents in a sense, and also performance. We wait a few more minutes before we actually start to let people who are maybe a little bit late to join. So I'm here with Dipankar and Alex.
Hello.
How are you today?
Good,
Uh,
good. It's a good day.
Same for me, yeah. How are you doing?
Where are you located geographically at the moment?
I'm in Toronto, Canada.
I'm in right now. I mean, I'm based out of Orlando, but I'm currently in San Francisco. I've been doing a lot of events in the Bay Area this week.
Okay, so we are in three different time zones.
Yeah, I think
I'm
you're
in
in
Israel
Israel,
at the
so
moment. So here it's 9 p.m. So
Here's 11
we
a.m.
2 p.m. So all different geographies, yeah.
no, so super excited to be here. We had like 350 um, registrations to the webinar, which is really exciting. And I can see already people are joining in. So welcome everyone. Let's start with short introduction. Feel free to elaborate about yourself and what you do at the moment at your place. So Dipankar, please start.
Yeah. Thank you so much for having me, Daniel. Yeah. So I am Dipankar. I currently lead developer relations at Cloudera. I just joined like 2 months back. And my focus is on developer initiatives worldwide towards Lakehouse and Open Lakehouse and generative AI. Before this, I have served in various developer advocacy roles back at companies like Dremio, OneHouse, Click, and before that, I was involved in various engineering roles like software and data engineering. The past couple of years, I've been involved primarily on the open lakehouse architecture, working with table formats like Iceberg, Apache Hudi, and Xtable that provides some kind of interoperability. So I've been contributing to these things from various perspectives, from educational perspectives, from the community building perspective, and have really seen the shift kind of overall through these years. And I'm super excited to be here.
Happy that you joined, and I want your microphone. So afterwards, tell
Awesome.
me which brand it is. It's super cool. Yeah,
Bringing
and
the vibe.
Alex,
Hey everybody, my name is Alex Merced. I'm head of DevRel at Dremio. I've been at Dremio for 4 years now. Basically, I wake up every day. I talk about the data lakehouse, about Apache Iceberg, about Apache Arrow, and so forth. And basically, I got to work with Dipankar for quite a while over there at Dremio, and it was a very great partnership. We got to work on some great projects together. We got to work together on a book. It was good times. Basically, yeah, nowadays I just talk about Iceberg. That's basically what I've been doing all week at several events here in the Bay Area. And yeah. Basically, I would say basically in the early days when there was early days at Dremio, me and Dipankar were basically the two voices out there in the space talking about Iceberg when before Iceberg really became cool. We were the Iceberg hipsters.
Right.
We were there before it was cool.
became cold.
So
It's not just kidding.
Yeah,
yeah. But
absolutely. Yeah.
basically it's exciting to kind of see how far things have changed since then. Before it was a struggle to get people to let us talk at a meetup about Iceberg. Now it's like it's hard to find a meetup that doesn't want us to talk about Iceberg.
Exactly.
So let's see if we can talk about Hudi instead. No, okay, maybe about Spark.
Yeah, we'd love to. Yeah,
About
for sure. Yeah.
by the way, to the listeners, Dipankar and Alex worked together like 3 years
Mhm,
ago, and I
mhm.
didn't know that when I approached them both. So that's a super
Right.
cool coincidence, and
Yep.
shows how in a sense, the industry is distributed all over, but there's
Mhm.
still some connections.
Community over code, I
So
guess.
yeah.
Yeah.
So super happy that you're here. I'll give a few words about myself, what we plan to do here, and also about DataFlint. So I'm Daniel Arnovich. As you can see, the description says Chief Host Officer. So specifically for this hour, I was promoted at the company, but usually I'm the CTO and one of the co-founders. And my background, actually, Dipankar, is also similar to yours. I came into data engineering from data science. I studied actually more physics in my undergrad and also my master's. And I do have a podcast that I go over historical papers in data science. And historical, I mean, it could be even 100 years ago, but it's for fun. It's called the Data Science Decoded podcast. But this is the first webinar that I'm hosting, so I'm also a little bit excited, which is cool. And after like doing a lot of data science, I was introduced to Spark several years ago and was like, oh my God, what's going on? I did like show df every 2 lines of code, and then of course it's an action, and nothing really worked, and I didn't understand why. So I dove deep, then worked a few years at a company that accelerates Spark with hardware. So then I went a little bit into the internals. And the last year and a half, I'm a DataFlint. And in one sentence, what we do is we help data engineers that work with Spark make it more efficient, help debug and optimize jobs. And of course, if it's teams, so we give a lot of observability. And I guess, I don't know, Dipankar or Alex, have you ever worked with Spark and actually tried to do stuff?
Absolutely.
Curious.
Yeah, all the time.
Yes, all the time.
Okay, cool. So often I ask describe Spark in one word, and I get a few answers, but I think 80% of them is pain.
Right. Yeah.
So that's why I felt it myself. So that was my motivation. I just shared the screen. I want to give a few sentences about our open source. So actually, you can see our website, and we have a copilot for Apache Spark. But if we go to our open source, that's where my suffering started, is trying to debug Spark, and you get the Spark web UI. That's probably the only tool that you can use. Also, if you're on Databricks, you get a similar web UI, and it's not enough. It took me a year to become an expert and understand what's going on. So our open source, the DataFlint open source, adds another tab. So when you open the Spark Web UI, you get another tab, and we give like a TLDR of what's happening in the job, pinpointing also bottlenecks and suggestions on how to fix stuff. Super cool, open source. We don't extract any data, so it stays in your cluster. And I said to say no AI. It's all classical code, hard-coded rules, but it works super cool, our open source. So for sure, check it out if you're working with Spark. So this is about DataFlint, and the plan for the webinar is to go over today Lakehouse, hopefully understand what it means, at least how we perceive it, and how agents fit in. Talk a little bit about what was the history and what's the future. And in general, the plan for the webinar is to do one every month, every 2 months, and I enjoy speaking with cool and interesting people. So I'm happy the company gives me the platform, although I'm a co-founder, so I have some say there. They're not always listening to me, but now they did. So let's begin. And I'll put a hat of a practitioner. There's a lot of buzzwords running today, and I want us to reduce the noise and increase the signal. So if we like use the word lakehouse, right, a data lakehouse, first I want to define how you see it. So maybe Dipankar, you start, and then Alex, you can add how let's say you talk to a data engineer, how would you explain it to him?
Yeah, I think obviously like the canonical term that and the definition that people, you will see in blogs and stuff is that data lake house is a combination of a data lake and warehouse. But obviously the kind of the best of the both worlds in a way. Uh, and there is a reasoning for that, right? I mean, the way Lakehouses started was basically like, you have your BI and more structured data workloads running on your data warehouse systems, right? But they were not that great for like, kind of advanced analytic machine learning based tasks. Specifically like companies working on like deep learning based technologies, more multimodal images and documents. They needed somewhere to dump that data, right? So data lake eventually became that, starting with the Hadoop era, became that place to like, okay, this is a storage system. This is where I'm going to dump my files. Doesn't matter structured, unstructured data. It's a great way for me to store the data and have a repository, right? But there was no governance, though there was no like security around. I mean, security was still there in some way with that technologies, but there was no governance, lineages, and explanations towards how the data was organized and stuff. So basically, you're running a two-tier architecture, right? One is a data warehouse for your structured workload. One is a data lake for your unstructured, which means typically more cost for, hiring specialized engineering resources. Overall TCO gets super high because you need tools specifically. And also we know from the Hadoop world, the set of tools that comes with the dependencies and stuff. So it was really a burden in general. Hiring the specialized resources plus the cost was high, and how do you manage at the same time, right? So there was the need of a unified platform or an architecture, some sort of a blueprint. That's what an open lakehouse bring. Now what's open is basically, it kind of like leads to the another part of the discussion, which is like our table formats. That's particularly a particular component in that lakehouse architecture that makes everything like open and interoperable. But if I today like go and explain, I actually published a paper as well, back at my time at Dremio. How do we kind of correlate a data lake house with a data warehouse or any kind of database system, right? So for me, it's as similar to any kind of a database system, right? They also have the file format, the storage format, the table format, the catalog or whatever it is. But all of those are bundled typically into one particular monolithic system, right? Whether it was Oracle DB before, Microsoft before. And now what we have done is we are basically like allowing people to like go like Lego mode, and they can like put together things in their own way. I mean, I'm not saying that you have to build these things up like for that. You can obviously go with vendor platforms who are doing that already. But there is an ability to be more flexible and modular in nature. And that's what a data lakehouse primarily bring, the openness and the modularity part of it. Probably Alex can add
Yeah.
some more context towards that. Yeah.
Yeah, Alex, I want to
Yeah.
hear your thoughts. Do you agree?
Yeah, no, I mean, I 100% agree with all of that. I mean, essentially, all the data lake houses is just taking the black box of a data warehouse, breaking open that box, and saying, how can that look like? So essentially using your data lake as your storage layer, having a table format that allows you to organize that data into distinct tables, like Apache Iceberg, then having a catalog like an Apache Polaris that is aware of those tables and can determine who has access to those tables so you can govern those tables. And with that, now you have an interface where you can interface with your data stored on your data lake in the same way you would interact with like a Snowflake or a Redshift and so forth. And that's the beauty of it. And then also the beauty of that is that different departments can use different tools. So you're no longer having the ETL between different departmental warehouses, which creates a lot of redundant work, a lot of redundant costs, and a delay in being able to deliver like BI and AI workloads.
Got it. So if I'm trying to reiterate what I understood, so let's say around 10 years ago, right? Makes sense when the data lake was already a thing, right? Because you had due to the cloud coming, we have separation of compute and storage, and now you can store things, but then use different compute engines on top. So that was the data lake. And then I don't know, like who was in the industry back in the time? What was the sentiment? Like we wanted to be more like a database, or how do you see in retrospect the history and the progression to
it came at a couple
saying,
different
okay,
angles.
okay, interesting.
Yeah, like it depends what you're talking about. Like there's a different story for like Delta Lake, Apache Iceberg, Apache Hudi. They were all trying to solve different problems around the same time. But fundamentally solving the problem they were trying to solve, whether it was trying to make Spark more the all-round engine with like Databricks trying to really build a business around Spark, so that they wanted to make it easier to to have the same kind of guarantees as in a data warehouse on your storage, and so that way you can use Spark as your main engine. Then you have like Iceberg, where Netflix was having a lot of sort of friction with Hive when working with their data lake. And they were trying to basically improve upon sort of the frictions, like the lack of asset guarantees, the lack of concurrent updates, things like that they were experiencing with Hive. But the result is they created a data warehouse. Now, as far as like the problem that was being solved, particularly with Hudi, I want to leave that to Dipankar because he would know that a little bit, that story a little bit better than me. So I will defer that to Dipankar on that piece.
Yeah, I mean, pretty much the same story, right? I mean, Hudi started at Uber, just like how Iceberg started at Netflix. And I think the goals were kind of a little bit like, from the main design point of view was like, okay, how do we enable more mutations, right, on the data lake, which was kind of absent, right? Most importantly, the focus that I want to like bring on is the lack of kind of a storage engine that you typically
You
see
said
in a data.
mutations? Sorry to
Yeah,
interrupt
like
you.
updates, deletes, like,
Mm,
more
okay.
upserts, the ability to like make more like changes and updates, right? Which was extremely hard in the data lake, right? Because, everything was a Parquet file. The only mechanism was to like make a copy of that same version of Parquet file, which is super
Yep.
expensive, right? When you are kind of like reading that file, opening it, writing the record, closing the file, and you do that at a petabyte scale, it can be
You
such
have
a
a
pain.
folder final.
Exactly, exactly.
Or
So
updated 5.
right. I mean, so it just was not like optimized in a way, right? From a storage system perspective, from a compute perspective, right? And also like to the point of like Alex's mentioned, like the Hive table format, most important. Like, I mean, again, Hive is a nebulous term. Hive is, there is a compute as well. There's a table format. That exactly was the reason. I mean, there were a lot of challenges with Hive on the cloud object storage, right? Not on the typical physical like data files, data storage system like Hadoop, for example. Like Hive was meant to be for Hadoop, right? But when Netflix wanted to like look at like their cloud workloads coming in, right, moving into the cloud, they had this problem of like, the directory level like partitioning strategies becoming like core performance issues, right? There were no reliability guarantees as such, right? So I think these were some of the exact same reason that all of these table formats, like whether it's Hudi, Iceberg, they started at different camps to solve similar kind of problem, but with some focused goal. For example, Iceberg, so the main focus was like, how do I make like tables in a data lake environment, and the schema around that more like moving like schema evolution and partitioning evolution. So those were, I think, some of the really like holistic goals from different perspectives.
Cool. So my follow-up question, and I'm putting here like my physicist hat. So you said, okay, we have a lot of Lego blocks, right? And let's say I am now the chief architect in my company, and I'm in charge of the data lake. Sorry, the lake house. So I have my storage layer. Then we have the table formats that you mentioned, be it Hudi, Iceberg, Delta Lake, whatever I chose. I have my compute engine, let's say Spark, because I like Spark. And then, I don't know, maybe on top of that, I chose um, something for governance. And so I have a few tools,
Mhm.
right? Each one has different configurations. So what I'm saying, there's so many degrees of freedom,
Right.
right? So the question here is would you, I don't know, tackle it, but let's say you give in some tips or advice to somebody who's
Ah,
like trying to do stuff like that without talking or recommending a technology, just how to, this concept, how to build it properly or think about it properly.
well, this is perfect because like basically right now I'm putting the finishing touches on my latest book, which is Architecting an Apache Iceberg Lakehouse, which is literally answering this problem. Like, how do I go through the
Uh,
process of
uh,
determining these things?
We didn't
So,
agree on these questions prior, just to the audience. That was,
but bottom
yeah.
line is, regardless of what you choose in the end, don't skip the step of understanding what you have already, like talking to the different like stakeholders, like talking to your analysts, talking to your data scientists, talking to your data engineers, talking to your business users, understanding sort of what are the platforms you're using now, why did you select them when you selected them, what are the frictions that people have currently that they don't like about it? Like, what do they like and what do they don't like? Because you don't want to make sure, you don't want to end up losing what they like, but you want to make sure you fix what they don't like. And so basically, I would like kind of talk to the data analysts, data engineers, and just be like, okay, what is your experience? What are the friction points? But then I would talk to the business users and kind of talk about like, okay, at the end of the day, like, what is the value you're trying to get out of your data platform? Because even if I make it easier for the data analysts and data engineers, the question is also, are they building the things that the business needs? So making sure you would talk to the, the end business decision makers, see like, what is the information they actually need? When do they need it? How do they need it? So that way you create a platform that's easier to use and doesn't bottleneck the data analysts and data engineers and doing what they need to do, but also pushes them in the direction of building the specific things that actually serve business value. But if you just start saying, hey, I want an iceberg lake house, or I want a lake house, and just start plopping things together without kind of thinking through these things, you end up leaving a lot of value on the table.
Yeah, and it could happen a lot because now it's cool, right? Or
Right.
as I said prior, it's iceberg, it's code, but now maybe people are jumping too early on this bandwagon without actually thinking what my users at the company, the stakeholders actually need, right? Makes sense? Or
Yeah.
Yeah, I mean, I don't think it's like I would say, I don't know if it's, I think the lake house should serve most people's needs, but how you design your lake house requires some upfront research and thought process before you just implement it.
Absolutely. I think
cool.
one element that I wanted to add was like the security and the governance elements towards that. That is one area like in the past couple years I have seen a little bit more like less focus overall. It only comes into play when you're going to the stage of like exploration to like deployment, and then the POC gets into production, right? So this is where actually it depends, right? You start leveraging your cloud provider services or the governance policies around that. But my point is basically like there should be something independent from the compute and storage, because all of these layers in a lake house are technically more modular. So the way I'm thinking is that there should be something more like integrated set of like security and governance layer that ties up all of these different elements together, whether it's the catalog, and I know there is a lot of work happening around like vending credentials and some of the things around that. So I think some of these catalogs, for example, like OpenWen and Polaris, for example, has started some of these more detailed discussions around that, and how we can like kind of have that layer built in um, with that overall Lakehouse architecture would be key, because ultimately you are thinking from like from like your organization goal. You might be a financial institution, you might be like a telecom vendor or whatever it is, but that's an important part that I have typically seen in kind of deployment, that is it only comes into the play towards the later phases where it should be in a little bit more consideration before.
100%. 100%. Like basically when you're playing around, like a lot of times people will start playing with the table formats without thinking about catalog. And you want to start do your playing with catalog, because you want to see what those, because oftentimes the catalog is the governance mechanism, as Dipankar mentioned, with like things like features like credential. Then actually, let me talk about credential vending or credential vending for a moment, because it's such a cool feature. Because typically what would happen is that you would give, for someone to do queries in your data lakehouse, you have to give them access to your storage. Now that's fine. Like, hey, now I can go run my query with whatever tool, Data Fusion, DuckDB, Dremio, Trino, whatever. But the
Spark.
thing is that but they still have access to the storage. So they theoretically could go one day by accident, go into your storage, and then try to alter some Parquet file that's part of the table and break the whole table. So generally, you don't necessarily want to give them direct access to the storage. So this concept of credential vending, which has become like a thing in the Iceberg catalog world, is where the catalog will actually give the engine a temporary set of credentials. So in this case, I don't have to give the user storage credentials. I'm just giving them catalog credentials, and then the engine that they use will be able to receive credentials to access the storage just for the transaction that it's doing. So in this case, the user will never directly access those Parquet files. It always has to go through an engine that is able to authenticate through the catalog. In that case, and that allows your business users to be able to query the data without being able to break the table by handling the stuff that's abstracted underneath the actual individual Parquet files directly.
Unless your engine breaks something, because you.
Yeah, I mean, if the engine breaks the Parquet file, then that's an engine problem. But it won't be because the user had access to
No,
it.
I know.
But hopefully engines aren't breaking your Parquet files.
Yeah, I know. That was a semi humorous comment. So actually what you said make me think, okay, now I have this Lakehouse architecture, and I wanna, one of the, let's say, aspects I wanna keep in mind is performance, right? Sometimes it's the most important one, sometimes it's not, but it's one of the ones that I should keep in mind as the architect of my company. And then how you think about performance when we talk about Lakehouse? So would you put emphasis on the engine, compute engine? Like, of course, the answer is look at it holistically, but what does it actually mean, right? How do I actually tackle this? So maybe Dipankar.
Yeah, I can go and then Alex can add some context as well. Honestly, like the performance optimization, obviously, like there is this compute and the capabilities of the compute, and now also we are seeing like a lot of like JVM versus Rust discussions and coming in, and those kind of things are there. But from my perspective, I think the storage layer has some really good avenues to be in that shape that, okay, I'm gonna give you the best of, I'm optimized in a way that should be best for the compute engine to just read that data, right? So the thesis behind that is that the less data you are able to read, that gives you the most performant query, right? So that's the whole idea, that you should be able to read as much less as possible, right? And the ways to do that is, you use like pruning techniques, like data skipping techniques. So there are different methods to do that, right? The good thing is all of the stable formats, and primarily like with Iceberg, we have the ability to like manage that through Spark, for example. Like there are a lot of Spark procedures and stuff that allows you to like, really make the data in the best kind of shape possible. So like there are things like compaction, there are things like clustering, z ordering. uh, in a way, basically, you are optimizing the data layout as it should be in a way for the compute to consume, right? So, for example, most of the ingestions happen, right? When you're ingesting the data into the lakehouse, they're not ingested in a way that you would like your compute to be able to read. Like, for example, if my query is select star from this table where city is equal to New York, right? So when you're ingesting the data, you are not probably going to have that mechanism to ingest New York-based files into the same kind of file in Parquet, right? It'll probably be scattered around, right? Now, the way to like bring them together into one set of files so that your compute doesn't have to go and read each and every file and figure out what is the filter is basically like organizing them into one particular file. I mean, in reality, it goes into like a couple of other files, but that's what clustering brings, right? So you're clustering the data into one form, so that your query engine can actually go to that particular set of file and say, hey, give me the records from New York, right? So I think compaction, clustering, partitioning strategies, these are some of the things we kind of like have to focus a lot when we are kind of architecting for the like overall like the lakehouse operational journey. Because yeah, I mean, typically what I've seen is that you help people like with deployment, and they go from like, okay, I was in a data warehouse, now I'm in a data lake house. Now all I care about is performance, right? That's where your journey starts, right? Because you're going to end up getting more data as you kind of ingest more data, right? So I think that's my point.
100%.
Cool.
Basically, like when it comes to performance, you can attack almost every layer. I mean, but generally the two layers are going to be sort of like the most typical places of attack for like Iceberg or Lakehouses in general. Is one, the storage layer. So everything that Pankar just said about compaction, clustering, partitioning. And then the second layer would be some sort of caching layer, like between which different compute engines are going to do caching differently. But the idea is that on top of that, caching, whether they're caching query results or they're doing sort of other sort of variations of caching, such as like BI cubes or materializations or things like that. That would be sort of the other layer of doing performance. But now, of course, that can get tricky. This is definitely like those are definitely two areas where like Dremio particularly has made a lot of investments in on sort of how we cache and how we optimize the storage layer. But those are generally going to be the two mechanisms. Like there's other places you can, like for example, you could think about the file format. Like right now we have Parquet, and Parquet is great for lots of reasons. And Parquet improves. Like there's people who are constantly improving Parquet, so that way it can be compressed better, so that way it can travel over the wire faster, things like that. But then there's people who are proposing alternative file formats. Like you think of like Vortex, Lance, Nimble, that may organize those bits in a way that can travel even faster. So that right now there's like a thing in Iceberg where they're proposing a files API. So that way theoretically you could use other file types outside of like right now Parquet, ORC, and Avro as your underlying data files without necessarily as much work as it would be currently to kind of add that functionality. And so that there's that. But there's also how data moves. So for example, think of something like an Apache Arrow flight, where if you move the data as Apache Arrow buffers, it's going to be much more compressed and move a lot faster over the wire as well. So there's all these little areas where you can squeeze out performance. But fundamentally, like the reason why performance matters is not just getting your data, but also it reduces the cost. Like at the end of the day, if you can get the same performance with less compute, you're going to be better off because, hey, if I can, then this is where, again, another place where I want to mention Arrow again, because it does allow that same level of compute to be able to process a lot more data because it's able to handle so much data or more data in the same amount of memory than it would be in sort of traditional sort of processing pre-Arrow. But yeah, there's lots of places to optimize.
No, I loved your answers because I think that the knee-jerk answer for many practitioners is say, okay, well, if I have performance, I'm gonna throw more compute on it. And I see it often. So
Yeah.
I'm super happy with your responses because I totally agree. Yeah, move less data for sure, or work on less data. Try to do that if you can. So let's say the storage layer and the table formats, if you can squeeze things there and arrange them and improve it, yeah, that's something that I totally agree and reinforce. So perfect. I think we're in a good stage to have somebody else enter the chat or enter the webinar. It is the AI agents, and I'm gonna let them in. So I'll start by asking, how would you define an AI agent? And actually, Alex, I'll give it to you first.
Okay, so yeah, I mean the way I would think about it is first we had LLMs in a sense. So I basically had the ability that I can write text, a text prompt, and get a text response. And that's great. Like there is so much, I mean, we all use things like ChatGPT, Gemini, Claude on probably a daily basis to ask all sorts of questions, get responses that make us more productive. But, if I were to sit there and say, hey, can you write this email for me? I still then have to copy and paste the email, hit send the email, put the name of the person's email in the box. There's all these things, actions I still have to take to then use the output of the LLM. So the idea is like, okay, how can we make it where AI can take more actions on my behalf? And this is where we start getting to crossing the line between just a standard LLM chat experience to an agentic experience, where now the actual AI is taking actual actions on my behalf. So this is where like originally like frameworks like LangChain came in, where I could create functions that would do those actions. Like, hey, here's a function that puts all the email names in there, then puts the body of the email there and hit send. Okay. And then these tools would then be exposed to the LLM, and basically the LLM would just receive like in the prompt would have embedded like, here's the tools you have available to you, and here's a description of these tools you have available. And now this enables the LM now to actually call these tools, to call these functions. So this is two things. Now the AI can take action. Thus, this is where it crosses the line from being AI to AI agent. But two, it also changes the paradigm of how we develop software going forward. Because now everything is becoming agentic. We're no longer, before everything we developed was very deterministic outright. You would say, okay, step one, step two, step three. Like the logic was always going to be the same. The path is always the same. You kind of designed it to be very like, this is how it works. Now you have to kind of design software to think through sort of what are the different paths that the AI might go down, and how can I anticipate the possible AI paths and give AI the tools for it to get to the answer itself, which again just fundamentally changes how we develop software. We're still writing the same functions, but we're no longer thinking of them in a sequence. Now we're thinking of them as individual pieces that someone else is going to use. And we're going to think through sort of how they're going to use them and how to prevent sort of negative outcomes and how to nudge towards positive outcomes. And that's the agentic AI software development world that we have now.
Cool. Dipankar, what are your thoughts? You agree?
Absolutely. I think yeah, I mean the way to I think the more intriguing element, like, and I've been experimenting a lot of things lately in general, like how everyone has been doing in the industry as well. But basically, like contextual agents is something what I'm experimenting with right now. I think that one of the main goal would be like, yeah, there are a lot of like task in general that I think from even from a data engineering perspective that can be delegated to something like an agent, obviously with the right kind of like security and governance around that as well. But I think contextual agents like have, I mean, and that's where we are kind of like moving towards the discussion of lake houses and agents and where they can kind of fit in well in a way.
Mm-hmm.
Is that we need the right set of context for these agents, right? And that context can be provided by a centralized repository of some form, which typically can be a database system, it can be a file, doc, whatever it is, more simple form, right? But because of your foundation and if you're an organization who is already into that open lakehouse journey, it just becomes kind of just the next thing to do, right? I guess like how do you make sure your data that is sitting inside certain set of tables or even the metadata, think about it from an iceberg perspective, right? Iceberg's metadata is like the hidden kept secret in a way. You can query those table, right?
Mm-hmm.
So how I'm thinking is that, and this is one thing I've been experimenting lately is for example, like I have an Iceberg MCP built, right, that has two functions. It can get me the schema, so that way I can ask my agent without even going to query and all those things, tell me a little bit more about the tables, right, that I'm working with, right? And how I can execute some queries through that MCP via some kind of open compute as well in there, right? So, so really it's a matter of asking like, hey, like, is my Iceberg table like healthy? Like, are there any smaller files, right? What does the history look like of this table? Has there been a lot of like concurrent updates going on in this table, right? So because in a lakehouse architecture, typically like end up with this common question, which becomes more like routine maintenance. I think there is an ability to like get these agents and be more preemptive and prescriptive maintenance routines. So they can actually like help me get this information and kind of like prompt me to do something else based on that, right? And that's where a human in the loop would be involved, right? An engineer in the loop in this case, and that's where the decision becomes more rigid and trustable as well, right? I think so that's where the contextual agents I think fits in a little bit more for me.
Interesting. So maybe it's a little bit a cheeky question, but we had in software various automation tools for years, right? How do you see today, maybe in the future it will be different, uh, agents that in a sense are different? Because what you described, Dipankar, they automate some part of your job,
Mhm,
right?
mhm.
Hopefully
Yeah,
it will be deterministic, the output, which is
yeah,
not always the case. So
right.
what do you think about that?
I think like the angle is basically like if you mean like from an orchestration perspective, and we are seeing that happening. A lot of orchestration tools in the market are now thinking about how they can literally like because in a more simpler term, a AI pipeline is a data pipeline, right? I mean, if you think of it right from that perspective, right? The tools and the compute are a little bit different used there, but really it's
Mm-hmm.
a data pipeline. So if there is a possibility for me to tap these agents into that orchestration framework, which already like certain tools like Crew AI and other smaller vendors in the space has been doing, even for us in Cloudera, like we focus on like kind of orchestrating these agents. So how we can have like multi-agent framework. So you can have a master and they can delegate some tasks to some other subtask around that, which will depend on, for example, I need to get data from Iceberg and Redshift database, and I need to work on this to query federation using Trino, for example, and do something out of that, right? So this is where your orchestration frameworks comes into the play. This is where other tools, even for that matter, like some of the things that comes into the mind are like airflows and dexters that we have had all towards now. They are actually like they can actually be that host, right? And they can actually be the provider of that and more efficiently maintain these things agents as more of a pipeline thing. So if anything goes wrong, what happens after that, right? Like there can be a lot of non-deterministic aspects to think about there,
That
right?
that would be my next question. Yeah.
Yeah, yeah. So how do you take care? And I was talking with someone like there is a project called Boplan, and they do this kind of like Git for code and stuff. So they have this ability to like branch out a particular like version of Iceberg, and that's where you can like safely run your agents for finding or doing something, right? And that environment is completely untouched from the production environment, right? So it's a zero copy form. You're still working on with your pipelines, but your agents are still interfacing with them, right? And the failures and the decision that you have to take based on the failure becomes a little bit more easier to do versus doing everything and messing it up in your production.
Thank you.
100%.
And
And yeah,
just a second, I want to tell the participants if they want to have a few questions. So feel free to write in the Q&A, and then in the last 10 minutes we can maybe answer some of them. And yeah, Alex, I interrupted you.
oh no, no worries. I was just gonna say is I concur with Dipankar, and one, Botplan is a pretty cool platform. So you know, it's a they do a great work at creating sort of a Python runtime for doing Iceberg workloads. But yeah, no, I mean that was it. Like actually saw yesterday at AI in the Bay a great presentation by Lena Hall from Akamai. I recommend people definitely look at her work. She's done a lot of really great work around exactly this question, like how do you incorporate like a human in the loop? What's the framework for providing context to AI in a way that makes it more deterministic and secure? And the presentation she did is put it way better than I could put it. So I would just really just recommend people to just go check out what she has to say.
Cool. Thank you for that. I'll also check it out for sure. I hope it will be on YouTube. And my next question is like how you see it moving forward. So let's say I'm again a data engineer. What do you think like the near future agents that I'll be using in my work? You can also say about the far future if you would like.
Um,
Yeah, Alex.
my my opinion is that everything is kind of moving like basically the world is moving towards a place where basically communication is becoming much more of a premium, like because your ability to communicate determines how well you prompt. So we're creating all this agentic AI and all this stuff, but it all still relies on our ability to communicate with that AI. So because even with code, I can just focus on very strict rules and create rules that always work, that are very deterministic. In this case now, parts of our determinism are going to be based on like, and again, of course, we can build in things that loops that help make it more deterministic, to help fix things, and like template prompts and all these things. But at the end of the day, like there's still going to be some sort of element that the end user has to have a skill of how they express what they want to express. So if anything, learning to be a good communicator is going to be sort of like the high end tech skill of tomorrow.
I love it. Yeah, Dipankar, what are your thoughts?
I think everything that Alex said makes sense. I mean, at the stage we are right now, specifically, like since I keep on like most of my days when I'm like researching around Lakehouse and AI and all this, like how they like intersect in a way. I think the one thing that comes to like very often that I'm seeing, so I'm trying to just get a sense of the use cases, right? I was just seeing a RAG use case by AMD, some talk with Iceberg, and they use some kind of RAG graph to like figure out, some of the things that they would want from their business perspective. Um, I think realistically, what we are going to see is that the raw ingredients already exist in any kind of architecture. For example, data lakehouse, right? Since we're talking about that, lakehouse pipeline, they emit everything in agent need, right? Whether it's a table level statistic, metadata growth, storage level kind of metrics, query patterns, shuffle and skew metrics from Spark jobs, and all those things, right? So the raw ingredients are already in place. The missing piece is obviously what we are trying to like develop, which is the understanding plus the action of that. The pattern that I'm seeing is we're building MCPs for like everything pretty much, right? We're building, you know, and that's how the first step looks like in a way. I guess that's where we have standardized in a way. Um, this is where we are kind of like opening up LLMs to find out the actual context and really like open to like different sort of tools and compute and stuff, right? I think this is where actually the open lakehouse fits really well to my earlier point. Because the data itself is in open, lakehouse is open, plus Iceberg, for example, enables various compute to like just plug in a way if they are supported already. It just makes sense, right, in a way to like, okay, we have the repository already. We need the right context and the agents and something like self-healing pipelines, something like the ability to like manage something on the storage part. They all become more relevant now. So that's my take in a way that okay, we are in a very nascent stage right now, but we are heading towards a direction where we are able to probably find some values from automating these things.
Thank you. I also love the answer, and I would say my high level thought on it is as actually I was talking to 2 years ago after LLM came out with my father-in-law who's been doing software since the 70s. And he told
Right.
me, oh, I remember prior to compilers, like 90% of our job was to compile our code. And
Yeah.
then compilers came and we thought we're going to be unemployed. So this is one aspect. The second is, and I think saw it in my career, we are moving higher in the abstraction layer as the
Mhm.
users, right? Maybe in 10 years
Right.
from now, people who know Python syntax, we're gonna call them low-level people, you know?
Yeah.
Uh,
Yeah, that is true.
so
Yeah.
this reinforces what Alex said. Like we as practitioners, our abilities to communicate, understand what the actual business needs, what the
Mhm.
stakeholders want, that will be our main tool. Because a lot of other things, in a sense, will be automated. But also today, even before LLMs, there's so many things in software that happening under the hood with linting, compiling,
Yeah.
etc. So that's my take. And I would like to take, I saw a few cool questions from our listeners. So first, the question, which is more like housekeeping, will the recording be available? Yeah, for sure. And we're gonna put it also on YouTube. So yeah, everyone gonna get it after we have recorded. And then we have somebody who's anonymous. He says, if we think there will be in the future an engine that will replace Spark, and they said something like Daft, etc. So each one, you can give me your thoughts.
Okay. I would say in my experience, and again, I'm going to say this from the framework of, hey, what do people use when they're grabbing something off the shelf, open source wise? Because when it comes to like commercial options for engines, like of course, I hope people will try out Dremio, but when it comes to like, hey, what's going to be the sort of that open source default? Um, Traditionally it's Spark, because traditionally we felt like most of these larger workloads needed to be done by multi-node systems. Now, a trend that you're starting to see more of because of just innovations and sort of how we store data in memory and how we transport data, and also the speed of hardware, you're starting to see that you can get a lot more done on a single node. And you're starting to see a lot of people move in that direction where they're doing a lot more single node processing. So in generally in that world, the two engines that I think of, they mentioned DAF, but usually the two oftentimes I'll see more often than not are going to be DuckDB, and then more and more so, I'm starting to see Data Fusion. And I mean Data Fusion mainly because it's an Apache project. Like a lot of people started building a lot on DuckDB, although DuckDB is a much harder project to contribute to and actually get a pull request sort of made. So a lot of people are going, okay, well, let's go to the Apache project which is Data Fusion, where it's much easier to kind of make contributions and be able to kind of shape the project. And you're starting to see companies like Baoplan, Spiral, Spice AI, and Spiral DB, all kind of really becoming contributors to the Apache Data Fusion project and really getting behind it. So I do see sort of similar dynamic of like, Delta Lake versus Iceberg, where, Delta Lake was a harder project to sort of influence in a direction that the main people didn't want to go in, versus sort of Iceberg being a project that anyone can kind of shape and influence. And that's sort of Data Fusion kind of going in the direction of becoming sort of like the main sort of open source engine primitive that's going to be building a lot of systems are going to be built on. So that would be my take on it.
Cool.
Uh,
Dipankar?
Yeah, I think that to answer the question, no, Spark will probably not be replaced. Again, like it comes to Alex's point, right? I mean, it's single node versus multi-node workloads. ML-based workloads. There are different geospatial workloads. I guess it's just different. Graph-based workloads, you name it, right? Uh, this trend is pretty much like same as we have seen over the years, right? In the storage space, we have seen that we always need competing technologies, and it's good, healthy competition in a way. Similarly, competition means innovation in some way as well, right? I mean, every time you publish a research paper, you based on something and then you publish it, right? So I think Spark is going to be there. Spark is going to be there for the pipelines that we have already seen. Maybe there is some kind of improvement to be made. I think Data Fusion Comet, sub project from Data Fusion that I want to give a shout out. A lot of the work has been happening on the Spark execution layers acceleration. So like projects like Velox, for example, Gluten, Data Fusion Comet. I would highly recommend checking them out if you're in the space of compute and execution acceleration and stuff. But there are some interesting work going on. So I kind of find Spark as very modular as well. You can take out the execution engine, replace the Volcano execution model with something else that can accelerate your maybe other type of workloads. Uh, and there are also like engines like Daft. There are other things that can be more for kind of multi-model workloads, like dealing with like images and vectors and whatnot. So I think Spark is going to be there, but we are going to see some improvements or different types of engines. Yeah.
Cool. I loved it, and I agree with your answers. As someone who worked on, in a sense, Spark
I was gonna ask.
Accelerator with,
Yeah.
yeah.
Right. Yeah.
But for sure, some kind of dominance will be
Yeah.
by Spark in the medium term, even.
Mhm.
Okay, we have more cool questions, so let me go over them. Andre asks, what your take on the future of table formats? Do you see them conveying or maybe converging into one format? Or maybe it's more about the interoperability. So
I
yeah,
I
maybe
can take
Dipankar start and then
yeah,
you,
I can take
Alex.
some part of that. Yeah. So yeah, I mean, in my experience, I think obviously like what we're talking about is like unification versus interoperability. Uh, I personally think like we are actually seeing different types of formats coming in, and that's the same in the file format space, right? BTR blocks, whether it's Vortex, Lance, whatever it is, right? Similarly, on the table format side, we are probably gonna see more specialized formats coming up. Like we have Duck Lake now, along with Hudi Delta Iceberg. But they're also like I saw something this morning, like index table for Spark based mostly. And there were some geospatial ones before as well. The point is that because we are thinking about like how we can make interoperability a huge aspect of this, we can think about how we can share like some level of metadata, between these formats, right? I think that is where the crux of it lies, right? For example, if you see Delta and Iceberg today, and that's my point of view, like in general, I do see there is a lot of like design level primitives changes happening in general, which is good. I feel like these were some inherent problems that, I mean, not problems problems per se, but like more of like things that could make things more better. For example, Iceberg's metadata tree, every time you write it, like there's a metadata tree that you write, it becomes cumbersome after a certain point in time, specifically if you don't have proper like maintenance routines and stuff. So I think like that's where more simplifications are happening, and I think that's where people think maybe Delta and Iceberg is converging. Yeah, I mean, like we can take design goals of like any other thing, any other software system, right? I mean, it's all like fair, I guess. But to the point of interoperability versus unification, I think interoperability is going to be crucial. Anyone, because Iceberg has become the most kind of the standard and open to different compute, different tools, vendors. I think if you make your metadata interoperable with Iceberg or something in that form, that is going to give you some kind of like flexibility and kind of like future guarantees. Okay, my data is probably going to be like in this particular way, or maybe if I need something else, I can bring something else.
Yeah, 100% agree with all of that. The only points I'd like to add is one, like the projects won't ever converge. I mean, there's a difference, like they'll all borrow from each other. Like all of them are seeing, hey, the other project had a good idea in this feature. Let's adopt a similar pattern. So you're starting to see like the feature sets converge. Like for example, people will
Yeah.
point out that Iceberg adopted like deletion vectors and There's a lot of things that were sort of in Delta Lake because those were good ideas. So they should be there. But at the end of the same day, it's an Apache project, which will always have a certain governance structure. So the projects can't merge because they have completely sort of distinct sort of ways that they're governed. But hopefully in the future, it won't matter. I do think we're going to end up in a future where, you know, you're already starting to see the early stages of this with a scan planning endpoint in the Iceberg REST spec, where it pushes a lot of the metadata planning onto the catalog. So in that case, theoretically, if you had, and if you kind of took that a little bit further, you could abstract away the metadata handling to the catalog, and then the engines don't have to worry about the actual format. They can just retrieve the list of files that they have to scan from the catalog. In that case, then in the future, you could have, you know, different patterns, or multiple patterns that work and still have interoperability, because the catalog would be the unit of interoperability. So I do think eventually we'll get there. So we'll see.
Cool. Let's do the next one quickly, so we get as many as we can. Ryan asks a similar question about the catalog. So would we see a convergence to a single catalog? He says Nessie seems very interesting, but also there's Polaris. Yeah, your thoughts.
I love Nessie, but I do see that everything's kind of. I do feel that Polaris has the momentum, and Polaris has a lot of really cool features that I think serve the broader interests more directly. So but I do have a very soft spot in my heart for Nessie.
Cool. And then a question which is about agents, so that's cool. By somebody is anonymous. How do you see data modeling and overall data architecture like the Medallion making sense in the agentic world in the upcoming years? So maybe Dipankar, you can say a few words about that.
Yeah, I haven't thought about that to be honest, in a way.
Mm.
The way I can think about it is like I was reading some RAG-based like Lakehouse article. The way I saw it is your lake. I mean, I'm going to bring Lakehouse everywhere I see agents in a way because that would make more sense from my perspective, not just generically. But the way to see it is that okay, yeah, in a Lakehouse architecture you will have the medallion. You might have a medallion architecture, and your agents need more highly contextual data that can make more sense for them, right? I mean, they are literally like dying for context in some way. Maybe your rags, your tools that by MCPs can allow to get that. So in the gold layer or the silver layer, you'll see more that kind of like shaped up data where it's more contextual and stuff. Versus in the bronze layer, it will be more like, you know, literally data everywhere that you can like get sources from, right? So that is the only way I can think. And I think it also applies to generically to other things that we have seen overall in the industry as well. So it's not something new, at least from like the way I'm thinking right now. But yeah, Alex, did you have anything around that line or?
Yeah, bottom line, anything that was good before, as far as making data more usable for humans, is going to make data more usable for agents.
Exactly.
I'll just reiterate, and that's actually from our experience at DataFlint, where we have an MCP for Spark.
Mhm.
It will make it more important,
Oh.
right? So let's say the medallion architecture, you wanna like baby feed, you know, your agent with the most pure information you can and improve the signal to noise. So yeah,
Right.
that would be super important. Okay, let's see if we have time for last question. One about Unity catalog. So someone asking which open catalog offers similar features like predictive optimization, auto maintenance, etc. I don't know actually the answer. So
Um, I honestly, I mean, you know, we are comparing like some of the premium features like predictive optimization and maintenance and stuff, auto maintenance. Honestly, like there are some projects that are being, for example, I don't know, like maybe Alex can add more context, but Lakekeeper had some capability to do something, but not predictive, obviously. But that's another open catalog, you know, to think about. But I think if I think about like more from my perspective and personally, like if I think anything like in comparison, probably Polaris is like is the one that has that right momentum in a way, and I think that is where especially with like, Iceberg and more generic formats, I believe like that is where I see a lot of momentum happening. So I would definitely like, if I have to think of it, maybe Polaris is the one. Like, yeah.
Yep, I concur.
Cool. Perfect. So we are right on time. And we also had great Q&A questions. Someone said thank you to Dipankar and Alex for your insights. So I also say thank you. It was a great pleasure and great fun
Thank you
chatting
so much
with
for
you
having me.
guys.
Yeah.
Super
Thank you.
appreciated. And we'll might see each other in the future.
Absolutely.
Who
Yeah.
knows?
I'll see you
We'll be sure
soon.
to follow up. Yeah. All right.
Have a great day, everyone.
Have a good day.
Thank you.
Bye.
Bye.
Bye.